Hey guys! Welcome back to my channel. Today we're going to be learning about naming, adding, and subtracting polynomials. Let's get started. So we'll start with naming polynomials. But what exactly is a polynomial? To understand this, we need the definition of a monomial. A monomial can be anything from a number, like 12, a variable, like x, a product of the two, such as something like 12x, a product of two variables, such as xy, or a combination of all four of these to create something such as 12xy squared. You can always add in more variables and exponents, but a monomial cannot be a sum. They can't have a variable in the denominator. They cannot have a variable exponent. And they can't have a negative exponent either. So this is a monomial. But how does a monomial play into a polynomial? So a polynomial is simply either a monomial or a sum of monomials. So this could be things like 12xy squared plus x squared plus 5. This would be a polynomial. So now that we've seen what polynomials are, let's move on to how to name these polynomials. So now we're on to naming polynomials. So each polynomial has something like a first name and a last name. The first name and the last names of each polynomial depends on what it contains. So the first name of a polynomial is going to be the degree at which the polynomial is set at. And the last name of the polynomial is going to be the number of terms in that polynomial. So the degree just means the highest exponent. And the number of terms is just how many of those monomials we have within the polynomials. So let's look at some things. If our polynomial has a degree of 0, then that means its first name is a constant. If it has a degree of 1, that means its first name is linear. Degree of 2 is quadratic. Degree of 3 is cubic. And anything beyond 4 is just going to be fourth degree. So if it has a degree of 5, then it's going to be fifth degree, and so on and so forth. For our last name, it is the number of terms. So if it only has one term, that means that it is a monomial. With 2 terms, it's a binomial. With 3 terms, it's a trinomial. And with anything above 4 terms, it's just going to be with 4 terms. So again, if it has 5 terms, then it's going to be with 5 terms, and so on and so forth. So now that we've seen how to name these, let's use some examples. First of which, let's have this right here. So let's name this polynomial. Our first name is the degree, or the highest exponent of the polynomial. So our highest exponent in this polynomial is our 2. So our first name it has a degree of 2, so it's going to be a quadratic. And its last name goes by its number of terms, so how many monomials we have inside. So we have a total of 1, which is the x squared, the second one, which is the 3x, and the third one, which is the 5. So that's a total of 3 monomials that we have, or terms. So if we have 3 terms, then this is going to be a trinomial for the last name. So altogether, this is a quadratic trinomial. Let's do a few more. So over here, let's name this polynomial. For this one, what is the degree? Well, our degree for this one, the highest exponent, we don't see an exponent. But there is an invisible 1 above the x. So, since it has a degree of 1, it's going to be linear. And for the last name, the number of terms, it is just one term. It's not being added or subtracted to anything or by anything. So this is just one term, which means it is a monomial. So this is going to be a linear monomial. Let's do one more. Our next one is quite long. It says 3x squared y to the fourth plus 5xy to the third plus 2xy minus 6x plus 4. The first name is the highest degree. So you may want to think that the highest degree is 4, but that's actually not the case. Our highest degree is actually 6. This is because the degree is not only the highest, it's the sum of all of the exponents in that first term, because the first term always has the highest exponents. So we would have to add 2 and 4 because it's in the same monomial, it's not in a different one. So we'd have to add 2 and 4, and our highest exponent or degree would be 6. And so looking at our chart right here, it says anything higher than 4 would just be written as 4th, 5th, 6th, etc. degree. So this is going to be a 6th degree. And then we need the number of terms. So this is 1 term, 2 terms, 3 terms, 4 terms, 5 terms. Looking at our chart, anything above 4 is just going to be with blank terms. So this is a 6th degree with 5 terms. And so that is its name. So now that we've explored naming polynomials, let's move on to adding and subtracting polynomials. So adding and subtracting polynomials are quite different from each other. When you are adding polynomials, all you need to do really is just combine like terms. However, when you're subtracting, oftentimes you'll have to distribute the negative. And that can get a little tricky. So let's try some examples to see how we can get this working. So let's say we have this polynomial that we need to add together. Our separate polynomials are inside of the parentheses, so we know that they're separate. And the addition symbol is in between. So that's how we know that we are adding here. So in terms of adding, all you need to do is combine your like terms, which we've done before. So we take all of the x squared terms, which is 6x squared and 7x squared, and we add them together. So 6x squared plus 7x squared is going to give us 13x squared. Our next terms are combining the x terms. So we have 3x and minus 2x. So 3x minus 2x is just going to leave us with 1x. That can be written as 13x squared plus x. And that is how we added those two polynomials. So adding polynomials is really straightforward. But what would happen if we took that positive there and we switched it, instead of adding, to subtracting? Let's see how that would change things. So over here, it might just seem like it's pretty straightforward. 6x squared minus 7x squared, 3x minus 2x. But it gets a little more complicated than that. Usually you'll have to distribute the negative. If you see over here, if you were under the impression that, okay, 3x, and to combine the like terms, we have to subtract, right? So you just subtract 2x. 3x minus 2x would give you just x. But that would not be a correct answer because it's 3x minus negative 2x. We can't forget that one right there. And so usually when we have larger terms, it just makes it a lot easier to just distribute that negative and then add everything together, so we don't have to worry about messing stuff like that up or forgetting that we had a negative in front of one of the terms. So that's what we're going to do here. Let's distribute this negative to 7x squared and to negative 2x. So for the first one, we'll have negative 7x squared, and distributing the negative to the second one, we'll have positive, because two negatives make a positive, positive 2x. So rewriting this whole thing would give us 6x squared plus 3x minus 7x squared plus 2x. So now all we have to do is combine those like terms. So we have 6x squared and negative 7x squared, which is going to leave us with negative x squared. And then we have the two x terms, so plus 3x plus 2x is going to give us plus 5x. So final answer is going to be negative x squared plus 5x. So really it's not that hard if you remember to distribute that negative. Moving on to our next example. Our next one is quite long. It says 20g to the third minus 56g squared plus 3g, and then we add the next polynomial, which is 50g squared minus 65 plus 8g. So for this one, it is adding. So remember, all we have to do is combine our like terms. So our largest like term is our 20g to the third, and there is no other g to the third term. So our first one is going to be 20g to the third. Now we add our g squared terms, which is minus 56 and plus 50g squared. So negative 56g squared plus 50g is going to give us negative 6g squared. So that's going to be our second term. Our third term is going to be our g terms. So we have 3g and we have 8g. So 3g plus 8g is going to give us 11g. So plus 11g. And what's left is our minus 65. There is no other constant term, so we're just going to have minus 65 at the end. So 20g to the third minus g squared plus 11g minus 65 is our answer. Now again, instead of having a new problem, let's see what would happen if we switched from adding these two polynomials into subtracting the two polynomials. So now we are subtracting our two polynomials. Remember what we said is that every time we see two polynomials being subtracted, we have to distribute that negative to avoid any confusion or any errors. So distributing these will give us negative 50g squared, and then negative times negative 65 is going to give us plus 65, and then negative times 8g is going to give us negative 8g. And then this is all going to be added with 20g to the third minus 56g to the second plus 3g. So with all of these, now all we have to do is combine like terms. So we have 20g to the third, and again, this is the only g to the third term we have, so that's going to be first, 20g to the third. Our next one are the g to the second terms. So we have 56g to the second minus 50g to the second. And so these two are being subtracted. So this is going to be negative 106g squared. Our next term is the g terms. So we have 3g and we have 8g. So 3g minus 8g is going to give us minus 5g. And our last one is going to be our constant term, which is 65. There is no other constant, so we're just going to add that in the end. So our final answer is 20g to the third minus 106g squared minus 5g plus 65. And if you're noticing, every single time I'm doing this, I'm keeping the answer in standard form, or the form that polynomials should be in, which is having the greatest exponent first, the greatest degree first, and then decreasing from there. So anytime you ever add or subtract a polynomial, you want to make sure that your final answer is in standard form. Let's try one more. So our last one says 65y squared plus 87y plus 6, and then we're adding our second polynomial, which is 89y to the third minus 70y squared plus 9. So this is adding polynomials, so again, we just combine like terms. First thing we're looking for here, though, is our highest exponent, so we can write it in standard form. So our highest one right now is 89y to the third, and there is only one y to the third term. So 89y to the third is going to be our first term. Our second one is going to be the y squared term, so 65y squared minus 70y squared is going to give us negative 5y squared. Our third one is just going to be the plain y terms, so we only have one of those, so that's going to be plus 87y. And our last one is our constant term, so we have plus 6 and plus 9, so that's going to be plus 15. So our final answer is going to be 89y to the third minus 5y squared plus 87y plus 15. Now again, let's switch this from adding to subtracting. So for this one, remember, we always distribute the negative. So we're going to distribute this to all three terms. So we're going to have our beginning polynomial, our first one, which is 65y squared plus 87y plus 6, and then we distribute that negative. So we're going to have negative 89y to the third, and then negative times negative 70 is going to be plus 70y squared, and then negative times positive 9 is going to give us negative 9. So from here, we combine all of our like terms. Oh, and I just realized that that is not a squared term, that is a third term. Okay, so now we have to combine all like terms. So we have our first term, which is negative 89y to the third. Remember, there is no other third term, so this is going to be our first term. Negative 89y to the third. Second terms are the y squared terms. So 65y squared plus 70y squared is going to give us plus 135y squared. Our next one is going to be the plain y terms, so we have 87y, so that's going to be plus 87y, and our last one is the constant terms, so we have 6 minus 9, which is going to give us negative 3. So our final answer is negative 89y to the third plus 135y squared plus 87y minus 3. So that's it for today, guys. I hope everything was clear and made sense. If you like my videos, please like and subscribe. Also, be sure to follow me on my Facebook and on my Instagram for more videos. Thanks for watching. See you next time. Bye!